Good morning, students. Myself, Shankar from EC Department, Chevrolet Engineering College. Today, we are going to discuss about the Laplace transform properties. In the last class, we discussed the three properties. One is a linearity property, and second one is a time shift property, and third one is a frequency shift property. Okay. In the last class, we discussed the three properties of linearity, time shift property, and frequency shift property. These three properties also we have in the Fourier series and the Fourier transformation also. Now let us go for the next property, the fourth property. Okay. Coming to the fourth property, it is also in the same Fourier and the Fourier differentiation theorem, nothing but the differentiation in time domain. Differentiation in time domain, d by dt of f of t. D by dt of f of t is s into f of s minus f of 0 minus. Here they are taking that it is a f of 0 minus. It is for the unilateral. It is for the unilateral, not for the bilateral, my students. What is a bilateral? S into f of s on. If it is any adding or the adding of minus f of 0 minus means that is for unilateral Laplace transformation. These are only properties different for bilateral and the unilateral. Remaining all it is the same. Okay, I will explain the bilateral, my students. Bilateral, and here they are explaining that as a unilateral Laplace transformation, the differentiation in the time domain. I will explain the bilateral. And the fourth property saying that differentiation in time, differentiation in time domain. Okay. What is the statement saying that d by dt of x of t is the Laplace transformation of s into x of s. Got it? Now take the proof. According to the definition of the Laplace transformation, x of t is equal to, not x of t, x of s is equal to. Now I am taking is a x of s is equal to integral minus infinite to infinite x of t e power minus st dt. This is a Fourier transformation, not the Fourier, Laplace transformation definition. This is a Laplace transformation. Now I am applying the derivative here. It is a derivative d by dt. It is not possible by taking off the Laplace transformation directly. It is an inverse Laplace transformation. You can take x of t is equal to 1 by 2 pi j integral sigma minus j infinite sigma plus j infinite, and the x of t becomes of x of s here it is, and positive exponential with respect to the s. It is a definition of inverse Laplace transformation. Now we can apply the derivative on both sides with respect to the t. So d by dt of x of t is equal to 1 by 2 pi j. There is no any t in this function, and integral is also not with respect to the time because it is with respect to the ds. So it is also constant because we are applying the derivative with respect to the time. X of s is also the constant. Only we have the t is there. So d by dt of e power st. Okay, my dear students, and ds. Now I can apply the derivative for this function only. Remaining all the terms what we have here is a constants is equal to 1 by 2 pi j integral sigma minus j omega infinite sigma plus j omega infinite plus j infinite x of s. What is the derivative of e power s into t? E power s into t. So what is the coefficient of t? Is a s. S ds. Now see this total function. I am taking the s towards here. X of s only, the 1 by 2 pi j, the integral minus infinite x of the. I take the s into x of s. Okay, right here. D by dt of x of t is equal to 1 by 2 pi j integral sigma minus j infinite sigma plus j infinite. Now s into x of s. You can write. I'm writing that as s into x of s as a one function. E power st ds. So according to that, it's comparing these two functions, x of t with x of s is a relation. Fourier transformation, Laplace transformation relation, x of s. Now instead of x of s, it is an s into x of s. Instead of x of t, here the d by dt. Means, therefore, d by dt into x of t is a Laplace transformation relation with s into x of s. What did my dear students? By using the inverse Laplace transformation definition, x of t is the Laplace transformation of x of s. But what we got after the applying the derivative with for the time domain function, there is a multiplication factor of s for the frequency domain function. So d by dt of x of t is a Laplace transformation paired with s into x of s. It is a bilateral, my students. I'm not taking the unilateral. For unilateral, d by dt of x of t, the Laplace transformation is s into x of s, and there is another function is there, x of 0 minus also. Minus x of 0 minus. This for unilateral. Unilateral, and this one is a bilateral. Remaining for bilateral and the unilateral, all the properties the same, but only the difference of differentiation in time domain property. Got it? Now see the unilateral Laplace transformation property here. What is a unilateral Laplace transformation? Saying that here the function f of 0 minus is the value of f of t at t is equal to 0 minus. The t is equal to 0 minus indicates the time just before the t is equal to 0. The 0 minus means just before the 0. 0 plus means just above the 0. In other words, t is equal to 0 minus is equivalent to the limit epsilon tends to 0, t is equal to minus epsilon. Got it, my students? And let us write that d by dt of f of t is a f dash of t. D by dt of f of t is a f dash of t. Consider the Laplace transformation of f dash of t by the definition. Laplace transformation of f dash of t is integral 0 minus to infinite. I am taking the 0 minus, my students, because it is a unilateral. 0 minus to the infinite e power minus st f dash of t. Why I am taking the f dash of t here? We are applying the Laplace transformation for the derivative f dash of t on. Now integrating RHS of the above equation by parts, we get Laplace transformation of f dash of t is equal to f dash of t is equal to, it is an integral of two functions. One function is a d by ds of e power minus st. Another function is a f of t. D by d, not the d by ds. Okay, d by ds only. It's not. I am saying it is the d by ds. See, the definition is integral 0 minus to infinite e power minus st f dash of t dt. Integration the RHS of the above equation by parts, we get by parts. What is the by parts here? The first signal is e power minus st and the second signal is the derivative of f of t. So e power minus st, and for the second signal, if I am applying the integration. Okay. See, the by parts I am applying. Taking the first signal e power minus st. For the second signal, integral of f dash of t minus integral and the derivative of the first signal. What is the derivative here? Minus s into e power minus st, and again the integral of f dash of t dt. Okay, so e power minus st, integral of f dash of t is f of t minus integral is already we have here plus s into e power minus st. What is the integral of f dash of t? Again, it is f of t dt. Okay. So e power minus st f of t plus s into integral f of t e power minus st dt. Got it, my dear students? So what is the limitations now here? I am taking the 0 minus to the infinite. Why it is a 0 minus? 0 minus is for the bilateral only. So bilateral function. So now I am applying the infinite here. E power infinite is a 0. And here also the e power infinite is a 0 for the second function. Or otherwise, I am taking here only the e power minus st f of t with 0 minus and infinite plus s into, and thus integral is the 0 minus to infinite f of t e power minus st dt. Okay, I'm not applying here. I'm taking only the integration. So e power minus st f of t is applying the infinite here. Infinite means 0, the first term. Lower term, if I am applying as a t is equal to 0. T is equal to 0 means e power 0 is a 1, and f of 0, f of 0 minus, that is a lower limit. So minus, it is a 0 minus f of 0 minus plus s into, this is a definition of for a Laplace transformation only with the signal of f of t, so f of s. Finally, the Laplace transformation of the f dash of t is equal to s into f of s minus f of 0 minus. Got it, my dear students? So e power minus infinite into f of t, f of infinite minus e power 0 f of 0 minus 0 minus only. And s into, I take the integral value is 0 minus to the infinite. So first term is a 0 and the second term is a minus, e power 0 is a 1, f of 0 minus plus s into f of s, s into f of s minus f of 0 minus. Okay, which is proved as for the bilateral. And similarly, it is further apply the derivative square term. It becomes of s square f of s minus s into f of 0 minus f dash of 0. Still it is increases. Third derivative s cube means n plus 1, and it is increases, and f dash of 0 minus is a s, and finally is f dash of 0 minus. And nth term, the Laplace transformation of d power n by dt power n f of t is equal to s cube. S cube is becomes of s power n f of s minus, and it is decreases. What is the decreases here? The n minus 1 f of 0 minus minus, and still it is a decreases s square, and becomes of s. So s power n minus 2 f dash of 0 minus, and so on. The last value is f double dash. So last value f double dash means for square here the first double dash is there. Okay, and for 1 it is there is no any derivative, and the nth term is n minus 1 times double dash it is. So second derivative for the d cube by d3, and now here the derivative is f power n. Okay, double dash here, and it is a derivative of d by dt of, for nth derivative, d by dt of n power n, d power n f n minus 1, and the 0 minus. Got it, my students? So like that we'll get the nth derivative also. Later. Okay. Come to the next property. So we learned the bilateral and the unilateral, my students, previously. For bilateral, d by dt of x of t, the Laplace transformation is s into f of s, and that is for bilateral. And unilateral for the d by dt of x of t is a bilateral Laplace transformation. Unilateral Laplace transformation is s into f of s minus f of 0 minus. Okay, unilateral Laplace transformation. Remember this one. This is only the property is the difference for bilateral and the unilateral. Remaining all the properties the same for bilateral and unilateral. Coming to the integration property. Integration property saying that so before differentiation property is s into f of s we got, but integration means differentiation is always multiplying the coefficient value, and the coefficient value is writing it as in the denominator for the integration value. Okay, so the integration of 0 minus 2 to 3 f of t dt is a Fourier Laplace transformation is fs by s, f of s by the s. As the definition of the Laplace transformation, it can go as the definition of the Laplace transformation, the integration of the 0 minus, actually it is a 0 minus to the t, not the infinite, my students. They're asking that integration theorem you have to prove for the limitation of 0 minus to the t only. If it is a minus infinite to t, that is a bilateral. Okay, unilateral is also the same. Minus infinite to t, f of t dt, substitute as f of t is equal to e power minus st by minus s, and integral 0 to minus infinite f of t dt. And applying the by parts, integration by parts, integration the above equation by the integration by parts, e power minus st, and integral it is f of t dt only, minus again you can take derivative of this function, and integration of the f of t dt. Why I am not writing the first term? The first term is a 0 there. Okay, the first term is a 0. You see here, e power minus st tends to 0 as t tends to infinite. This total function is a 0. Then the 0 plus 1 by s minus into minus is a plus. Minus into minus is a plus 1 by s. Integral 0 minus to infinity e power minus st f of t dt is a definition of f of s. 1 by s into f of s. What it matters to this? Integration in the time domain function, that is also up to the 0 to t only matters to us. 0 to t. But as per the definition, there is a 0 minus to the infinite. Using the integration by parts. Using the integration by parts. Taking the definition here directly, the integration 0 to t f of t dt, and apply the integration for this one minus, and derivative of this one is f of t, and apply again the integration here e power minus st by minus s. The first term becomes a 0 because infinite value is there for the t function. E power infinite is a 0 and 0 total value. Got it? And for second term only we have, that second term is 1 by s into the definition of Laplace transformation f of s. So 1 by s into f of s. Got it, my dear students? Or you can take the integration by the Laplace transformation. What is the x of s is equal to integral minus infinite to infinite x of t e power minus st dt. Okay. Now I am taking that e power minus st, the integral is e power minus st by minus s. E power minus st by minus s. If it is a derivative, e power minus st into minus s. Okay. For this is a Laplace transformation, inverse Laplace transformation, saying that is x of t is equal to integral sigma minus j infinite sigma plus j infinite 1 by 2 pi j as x of s e power s into t ds. Okay. The integration is applied for the input side. Integral 0 minus to the t x of t dt. And similarly here also you can apply the integral with respect to the t only for this e power only. In the right hand side also I am applying the integration 2 pi j integral sigma minus j infinite and sigma plus j infinite x of s, and the t term is in the e power st only. So integral e power st dt and the ds. So only the t term is a variable and the remaining all it is a constants. That is also from 0 minus to the t. Got it? Is equal to 1 by 2 pi j integral sigma minus j infinite plus sigma plus j infinite x of s. What is the integral here? E power st integral is a e power st by s with the limitations of t and 0 minus into ds. Okay. So apply here the upper limit and the lower limit. 1 by 2 pi j. I'm taking the e power minus st by s with the t and the 0 minus. Upper limit I am substituting with respect to the t only we are applying. So t is substitute the t. The same will get the e power minus st by s minus e power 0. E power 0 is a 1 by s. E power 0 by s. E power 0 is a 1 minus 2. E power 0 minus we can take that. So this value can eliminate the e power minus st by the s. 1 by s is there here. Again, integral sigma minus j infinite and sigma plus j infinite. After substituting the t value, there is no any change. E power minus st. And actually, if I am taking the 0 minus value, it is a bilateral, unilateral. If it is a infinite minus, infinite is a 0, the 0 by s. So x of s by the s e power st ds. Now see, now I can compare these two equations. Integral minus infinite to t x of t dt. What is the relation here? For x of t is a Laplace transformation of x of s. And integration for Laplace transformation, the of s is becomes of x of s by the s. X of s by the s. Got it, my dear students? You can do like this also. And nth term, the integration is applied for the n integrations. It becomes of s power n. See here, f of s by s power n. Understood? For the derivative, if you can apply the d by dt of nth derivative of x of t, what is the Laplace transformation? S into x of s. Now nth derivative is a n. D square means s square x of s, d cube means s cube x of s. And integration also, the second integral and the third integral you can apply. The t1, t2 and the tn. If it is a t1, s power 1. t2, s square. t3, s cube. tn, s power n. Okay. And these are the 5 Laplace transformation properties we discussed. Linearity, time shift property, linearity property, time shift property, or it is also translation in time domain. Third property, complex translation, translation in frequency domain. And fourth property, differentiation theorem, or it is a differentiation in time domain. And fifth property is the integration theorem. And differentiation property also we derive for the bilateral and the unilateral. Okay, because there is a difference for those two only. We go for the sixth one, differentiation by the s. We already seen that, we already discussed about the differentiation in time domain. Now it is a differentiation in the s domain. Nothing but is a frequency domain. Let the Fourier transformation of Laplace transformation of f of t is f of s. Then the differentiation in complex frequency domain. Differentiation in complex frequency domain corresponds to the multiplication by the t in time domain. Corresponds to the multiplication in the t for the time domain. Okay, multiply the t in the time domain. There is a differentiation occurs in the frequency domain. Now let us see the differentiation in s domain. Sixth property. Differentiation by the s, or in s domain, you can call it as s domain or the frequency domain also. Frequency domain. What is the statement here? The statement saying that the d by the ds of x of s in the frequency, the Laplace transformation for this one is a t into x of t. For the t into x of t, you can apply the Laplace transformation. We'll get the differentiation in the frequency domain, nothing but the s domain. Let me go over the proof. According to the definition of the Laplace transformation, x of s is equal to integral minus infinite to infinite x of t e power minus st into dt. For Fourier transformation and the Laplace transformation, here only the difference is instead of s, there is a j omega is there. Instead of s, there is a j omega. The shortcut notation of j omega, x of j omega is equal to x of omega. That is also the x of s. Simple. Wherever the j omega is there, you can substitute the s. It becomes to the Laplace transformation only. It becomes to the Laplace transformation. Following my students. Now, what they are asking here, the differentiation in the s domain. So apply the differentiation on both sides with respect to the s. S with respect to the s into x of s is equal to, here the s term is only for the exponential value. The remaining is a constant one, e power minus integral minus infinite to infinite x of t. Take the differentiation with respect to the x for e power minus st dt for this function only, and d by ds of x of s is equal to integral minus infinite to infinite x of t. Now what is the derivative of this one? Applying the with respect to the s, d by dt of e power minus st into the s coefficient is a minus t. S coefficient is a minus t. Okay, into dt. You're applying the derivative with respect to the s for the frequency s terms, and e power minus st with respect to the s coefficient is the t, that is a minus t. So d by ds of x of s is equal to integral minus infinite to infinite. Now I am writing the t into x of t as a minus also. T into x of t e power minus st dt. Now you can see here for x of t, apply the Laplace transformation, we will get the x of s. Similarly, you can apply the Laplace transformation of the t into x of t. Therefore, the t into x of t, the Laplace transformation is d by ds of x of s is a pair. Laplace transformation pairs t into x of t, the d by ds of x of s, the frequency term. Okay. So here, for the Laplace transformation of t into f of t, the minus d by ds of f of s. We are taking the minus here itself, minus d by ds of f of s. By the definition of the Laplace transformation, f of s is equal to, we are taking here the by unilateral, my students. Don't confuse. 0 minus to the infinite f of t e power minus st dt. I explained in terms of the x. Here they explain in terms of the f of t and f of s. D by ds of f of s is equal to integral 0 minus to infinite f of t d by ds of e power minus st dt. Okay. Then apply the derivative for the e power minus st into minus t. So minus the Laplace transformation of the t into f of t. So we got it is a Laplace transformation of t into minus t into x of t. Okay, my students. Now coming to the seventh one, initial value theorem. It is a very, very important theorem. It is initial value theorem. In this initial value theorem, we are using the unilateral only. Now, whatever here, they are representing the integral 0 minus to the infinite. For initial value theorem, we have to must and should, we have to use the unilateral Laplace transformation only to prove the initial value theorem. Don't use a bidirectional or bilateral Laplace transformation. So what is the statement saying the initial value theorem? It is a limit, not the limit, Laplace transformation of f of t is equal to f of s. Then the initial value of f of t is given as initial value of f of t. What is that initial value? I am assuming the f of 0 plus. 0 plus is the initial value. Here, what is the 0 plus means? 0 plus is the just above the 0. 0 and 0 plus and 0 minus. Just below the 0 is a 0 minus, just above the 0 is a 0 plus. So f of 0 plus is equal to limit t tends to 0 plus f of t, that is equal to limit s tends to infinite. So initial value, it starts from the time domain is a 0 plus and s domain is end with the infinite. So initial value 0 plus in the time domain, and in the s domain s tends to infinite, s into f of s. I have to prove the limit t tends to 0 plus f of t is equal to limit s tends to infinite s into f of s. Okay. Provide that the first derivative of f of t should be the Laplace transformable. We know that the Laplace transformation of the d by dt of f of t is equal to s into f of s minus f of 0 minus, by the definition of unilateral Laplace transformation, or one of the property, the differentiation in time domain. Differentiation in the time domain, my dear students. So now on both sides, if I am taking the limit s tends to infinite, limit s tends to infinite on both sides, limit s tends to infinite, the Laplace transformation of d by dt of f of t is equal to limit s tends to infinite, the total function is s into f of s minus f of 0 minus. Consider the Laplace transformation of the above equation, that is LHS here. Consider the LHS of the above equation. LHS is limit s tends to infinite. What is the Laplace transformation of the d by dt of f of t? According to the definition of unilateral Laplace transformation, the 0 minus to infinite. What is the f of, here this x of t signal is d by dt of f of t e power minus st into dt. So actually x of s is equal to integral minus infinite to infinite x of t e power minus st dt, the Laplace transformation. For unilateral Laplace transformation is integral 0 minus to infinite x of t e power minus st dt. I need the x of t, the Laplace transformation of the derivative of the signal. So x of s is equal to integral 0 minus the Laplace transformation is a d by dt of x of t, d by dt of x of t e power minus st dt. So this is nothing but the Laplace transformation of d by dt of x of t only, or otherwise it is equal to the x of s. Okay. So I substitute the d by dt of f of t e power minus st dt by the definition of Laplace transformation. Okay, when we can substitute limit s tends to 0, limit s tends to infinite, here e power infinite. What is the e power infinite, my dear students, in this function? The total function e power infinite is a 0. You know the e power infinite always is a 0, e power 0 is a 1. So, and I am taking here the limit s tends to infinite, e power minus infinite into t. Substituting the s value as infinite, it becomes of the 0. So LHS is equal to 0. Now, you can substitute this 0 value in this Laplace transformation of the d by dt of f of t is a 0, that is equal to limit s tends to infinite, s into f of s minus f of 0 minus. Okay. And in the second function, there is no any s terms. In the second term, there is no any s terms. So you can bring that into the LHS value towards the left side. Here the minus becomes is a plus. F of 0 minus is equal to limit s tends to infinite, s into f of s. Now here they are explaining that f of 0 minus indicates the value of f of t just before the t is equal to 0. And f of 0 plus indicates the value of f of t just after the t is equal to 0. If the function is continuous at t is equal to 0, then its value just before and just after t is equal to will be the same. Okay, my dear students, remember this one. F of 0 minus indicates the value of f of t just before the t is equal to 0. And f of 0 plus indicates the value of f of t just after the t is equal to 0. If the function f of t is continuous at t is equal to 0, then its value just before and just after t is equal to 0 will be same. So first f of 0 minus, I'm taking the f of 0 plus. So both are equal. F of 0 plus is equal to f of 0 minus for f of t is a continuous at t is equal to 0. Okay. Now replace the f of 0 minus. F of 0 minus as f of 0 plus is equal to limit s tends to infinite s into f of s. This equation is used to determine the initial value of f of t and its derivative. Initial value of f of t and its derivative. Got it, my students? It's very important.